Hi everyone, welcome to the second chapter of Wearing Flip-Flops. I'm Ronan, your host. With me, Ron Elani, our co-host, and we have a
Hi guys.
special guest today. Hi guys.
Last time we talked about the verification wall, the huge chips, and the long time it takes to simulate the chips, and all those challenges. And today we have Claudio, our expert,
Hey man,
verification
thanks for
expert
coming.
from Amazon. Claudio, can you introduce yourself in a few words?
Sure. First of all, thank you for inviting me, and it's my pleasure to talk to you guys. First of all, so I've been working in this industry, in the chip industry, for like 26 years, since year 2000,
Wow.
and been going through all the big
So you're at
companies,
least 26 years old.
at least, not far from there. And I started in 2000 as a verification engineer. I've been through several positions like technical leader and manager, and I've been in design and RTL implementation, post silicon validation, and but in general I've been most of the time I've been doing pre-silicon verification, which is my main specialty and my main focus during my career in companies like Intel and Apple and Marvell Semiconductor and the startup in the meantime. And in the last 10 years almost, I'm at Annapurna Labs, which is a part of Amazon. And I'm enjoying very much doing what I'm doing. I think verification is it's a great area to be specialized in. At least I think it's a combination between software and hardware and physical design. If you want, we will talk about it. And basically, you can see the full view of not only the chip design but also the system, which is it's something that is special to verification.
Thank you. Well, amazing. So actually it blends with what we started talking about in the previous chapter, because looking at some public references, for example, the Graviton 5. So it's estimated to have about 132 billion transistors, and the next gen could be even greater, 180 billion transistors. And having said that, how much time tests are running, what do you do in order to test such a huge chip? So, what methodology have you developed to cope with such sizes?
Okay, so first of all, I think it's not one thing that we are doing in a certain way. It's several things that we are, several approaches that we are taking in order to deal with not only with the size but also with the complexity and the timeline, and also, there are different kind of verification. If you look, you have the logical verification, which you want it to be like correct, right? To want to check correctness, but it's also performance. When you come out with a server, you must have, you must be, be competitive in performance terms, not only in, the chip works, so it's good enough. It's not good enough. You have to cover more than just regular verification as people are, using or regular or maybe get used to do. But without, even if I don't look at that, okay, and I look, okay, I say it's not only the logical, it's also the physical design, the design intent verification, which in most of the companies are, less the focus of the verification. But in our case, we do want to get into every area. And we also look at the challenges, okay? We have architectural challenges, okay? You have several aspects of verification. You have architectural, microarchitectural, and physical design, which we call design intent verification, okay? So we start basically by setting a strategy, okay? The strategy, it's per project. It also can, it's not, but this is the big one, which is very high level, right? And you have per subsystem, per unit, or per block, depends how we divide our verification, because you have to divide and conquer, right? Otherwise, if you do everything like, okay, I will do the unit level, or I will finish the formal, then I will start the unit level DV, then I will integrate it into the full chip, and then I will go to emulation. It will not take, we have a cycle of 2 years from production to production. This is what we have. And in these 2 years, we have to open multiple threads, okay? that do have dependency on each one on another, but we want to minimize those dependencies, okay? So we can talk about like reuse methodologies and stuff like that, okay, which cause dependencies. So we don't want, in my previous roles when I was in other companies, we have this reuse methodology. As you know, it was like a kind of belief, it has to be reusable, otherwise it's not good. So no, sometimes it's not good to have something reusable because you create dependency in both layers, okay? In the unit level, they have to be compliant to full chip, and in full chip, they have to integrate, and we don't want, for example, integration of verification. We want to be independent.
Yeah, that's a big trade-off.
Right.
It's a big dilemma in verification. The more usable you make the stuff, you're creating more dependencies. That's a good point. On the other hand, you don't want to throw away 2 years of work for the next project.
So we do have something that it's very, I think it's very specific, but it also creates dependency as everything that you want to. So we use for example, the operational software that will run from block level, unit level to silicon.
Mm-hmm.
What do you mean by operational software?
Operational software, for example, let's say you have an interface. Let's say you have a DRAM controller, right? And you have a driver. It will be used exactly the same driver from the unit level to full chip, then to emulation, and then to silicon.
So Claudio, just by the way, quick question. When you say the operational software, does that mean that you have the software like the assembly code or the C++ or whatever already on day one of the verification, that you can load it into memory or run through a separate process with DPI or whatever? How does that work?
So I will not talk about how we do it technically, but I will say,
the concept,
okay, let's say it's a C code, okay? It's a C code, abstract C code, okay? For any driver or any embedded driver that we have, okay, including the boot code, and we can run it in every environment. We have this, mechanism that we can take this software, and there are a few things that we are doing. So the one thing is we have the architectural modeling that software guys can also develop the software in a very fast way, because even if you take unit level or block level environment, it's still simulation, and it's still much slower than architectural modeling. So they do use both things in parallel. They are not dependent. It means if the software guy didn't develop this on architectural modeling, it doesn't mean I will wait for him to finish there and then we'll start my unit. No, I will start anyway, okay? And by the way, it's the same thing when we talk about unit level and then subsystem level and full chip. So we can work in parallel in full chip. We can in parallel bring up the emulation environment. At the same time, the unit level continues to work. We do communicate what it's working and what is not working at the detail level, but we do not stop anything in parallel. Everything must run in parallel. Otherwise, we will have to wait. This will not work, okay? We do concur and divide, but it's actually really, really concur, right? It's not like, okay, we do it in a serial way.
So, Claudio, we asked our listeners for topics that they were interested to, that we talk about. And here's one question from Daniel Joffe. I hope I pronounced your name correctly, Daniel. The question was, what's a good verification plan and how do you build it?
So, there are many ways in doing the same thing, and, you can take every approach and can do it well. I think the thing is not, I will talk about what we are doing and then I will say what I think about anything else. Other companies or other people may have a different approach and it will work as well as this one works, right? So we have the approach that we, first of all, before we are doing any verification plan, we do strategy plan. Strategy plan basically makes you think, how do I want to test the things? What are the environments? What are the platforms? What tools and what methods I'm going to use, I need to use, okay, in order to make this verification. This is not a test plan, okay? This touches the main challenges of any subsystem, unit, or full chip. But it focuses on what exactly, how do I divide the work, how do I use different tools in different environment, or in, how do I divide this in different environments? How do they look? What VIPs do I use? What formal verification are going to be in this block? Or, sometimes, for example, formal verification is not on a full block. They cover a part of the block, okay? And also in formal verification, you have to understand, it's not always foolproof. There are different approaches in formal verification, and you use them differently in different kind of designs. You don't use the same thing.
From your point of view, so we're talking about verification, we're talking about formal, we're talking about prototyping, we're talking about emulation.
Right.
Do you guys take everything into account in the strategy plan?
Exactly. That is the aim of the strategy. The end of the strategy is to make you think before you start to build the constraints and run simulation or build a formal. It has to be connected. It has to be synchronized. It has to be like multiple threads are running, and there is the thread that should the scheduler that should synchronize them. It's exactly the same.
Just for the sake of understanding of the personas in the room. So for the sake of the discussion, in your current role, what is your responsibility, and how do you make sure that what you plan and what the person next to you, if it's emulation, it's something else, how do you make sure that the strategy covers everything and there are no holes?
So when you do a strategy, okay, it's not like Divi has strategy and formal verification has strategy, and architecture modeling has strategy and emulation have strategy. No, the strategy incorporates all this together. There is one owner, always one owner, okay, but he works with all the stakeholders, and he's, at the end of the day, for example, I'm in Graviton, the person that is responsible for the product, right? For the whole verification. It doesn't mean I need to, I need to understand the full picture. I need to understand what platforms we use. Let's say about system level and subsystem. What subsystem are we going to? How we going to split? How we are going to split this chip in order to be able to run simulation effectively and not waiting for each simulation? You can imagine how long a full chip simulation can be in these huge, chips. It's without mentioning the numbers, you can imagine, right? So we
talked about the strategy. Let's go one level down. What's a good plan then? You have the strategy in place. You know what everybody is expected to do. Now you own the verification, right? So what's a good verification plan from that point on?
Okay, so there is something that, through my career, I had a vision always. When I do verification, I do not see only like the part of the verification that, like we talked about at the beginning. We have architectural parts, we have micro-architectural parts, and we have design intent parts, okay? So the thing is that when you start to write your test plan, you have to make sure, right, that you cover all these aspects and also the design implementation, wherever you can, okay? Sometimes you have IPs that you buy from a vendor. You don't really dive deep, okay, into the content and how they implement it. But you do have to know what different clock domains they have, what recent domains they have. You do have to know where the registers are located, and you do have to, not just physically, right? You have to know where they have the memories and where they have the FIFOs that you need to fill in order to.
That you're buying an IP from a Cadence, Synopsys, whoever, and then you go ahead and put it as part of the verification plan to actually test it
definitely,
as a standalone?
Definitely. Not always. It depends. It's, we have to be very careful because not everything you can do that. There are things that you cannot do that, even if you want, and it doesn't worth it, right? But in most of the cases where we can, that's what we do because we are, right, accountable for the tapeout. I do not care, I cannot blame anyone else. If there is a bug and Graviton has a bug, it's my bug. It doesn't matter that I can blame someone else. It will always be someone else that will blame, right? Because it's not me, definitely. But if I will look at the product or the project itself, it's something that in every place that you have the ability to do dive deep. We have these principles in Amazon. Think big on one hand, dive deep on the other hand, right? And then you have deliver results, and then you have insist on the highest standards. And this is something funny that, we always run very fast during the verification. Then we get to, for example, freeze review or something like that, and we are become very, we have these checklists that are very, very tough, and very, people are, getting scared. But you said you want to run fast. No, that doesn't mean that we don't want quality. So quality, right? It's not. So you cannot say, okay, I will do whatever I can, and this is what I can. No, it's not enough. So, but let's go back to the verification plan, because we talk about something else.
I was actually going to ask, do you guys use any advanced tools for creating the plan, like AI, or do you go like in the old days, or maybe, going paragraph by paragraph in the spec, or sitting with the designer, trying to understand the vulnerabilities? And how does the operation of building the verification plan for such a huge chip works?
So if we talk about AI, for example, it's in the last 2 years, let's say. So we do use AI a lot with documents. It's super helpful, but it does not solve you the problem of diving deep with a designer, understand the vulnerabilities, understand the architectural, and even, if you take the block level. So I will talk about verification plan. There are two things that you need to think when you do a verification plan. It's the what and the how. Okay, it's okay. Yesterday I was in a verification review. Okay, and there was something interesting, because there were very, features in the coherency and stuff like that, very complicated. And I said, it's nice, but another 2 weeks or a month, when you will come to implement those, we need to understand how you do that, because there is a very much importance. How do you check that? You say, I check coherency, I true sharing, false sharing, you name it, right? But how you do that? How do you know that you do the right thing, that you are really, challenging the architecture, challenging the design? You have to be specific on how, not only the what.
So when you say how, at that point, can you, for example, say, this feature has to be tested in formal and not simulation?
It's not enough, right? It's still the what. It's the what, and okay, this is strategy, right? In the strategy, say, okay, this block or this feature will test in formal verification. It's not the how. It's just the what and what tool we use for that. The how, it's what we are going to do practically, how the test would look like, how we are going to attack this problem in order to make sure that we do the right thing. And because if you do that, and you come to a meeting, and you explain the smart people that are sitting there what you are going to do, then they can give you real feedback. If you say, okay, I'm going to cover this item, everybody's happy, they will say, good luck, yeah, what a great test plan it was. But maybe it's not, you are going to do something that is really not good enough. It's never guaranteed. In verification, I will never tell you that I ever finished verification in my life, right? It's not something that can happen. But I will do my best in order to understand that I at least tried.
It's a good advice. And
it's a good tip.
Milani, do you have anything else you want to ask about that?
I guess I'm just curious, in what format do you capture the verification plan? Just like good old Excel, or do you have like something more fancy?
No, the simpler one you can imagine.
Okay.
It's we tried not to focus on the things that on the, there was one guy that I interviewed once, and he asked me what Gantt tool you are using, and I was, what Gantt tool we are using? We don't. What we are using, it's not a Gantt, or we have timeline, of course, and we have deadlines, and it goes without saying. But the thing that I think that we are focusing on, it's the mindset of the engineers, and the mindset is ownership. Right, it's also another principle of Amazon. That's why I think Annapurna are very, match Amazon culture. All these principles that I think that are really meaningful, because if you think about ownership, right? If you interview someone and you will ask him, what he would like to do is he will tell you, I would like to have ownership of something really important or a big scope, right? But no, not everybody understands what ownership means when it comes to practice, right? Because ownership, it's not easy, right? On one hand, it's fun because you have, a lot of things to think and to solve and, to deal with. But on the other hand, it's a deal of, you like a CEO of your own task. And you have to take it from the beginning to the end. I always give this example to my guys. I say, if your kid doesn't feel well and you go to a doctor and he still doesn't feel well, you will go to another doctor, right? And you will find another doctor until you get a solution, and you will never stop to look for the doctor that will
It's
give you the
your
solution.
problem, basically, and you
Exactly. Exactly, So that's what I mean. So the mindset, it's much more important than any tool that you will use or any, Gantt or a format or whatever. It's important. I'm not saying, everything has a benefit, right? And you do automation, it benefits, right? Because you have like more time to do the real thing. So if you do, the things that are like running regression and stuff like that, and so it really saves you time, but it's not solving your problem, right? It's giving you more like dealing with the real things.
Got it. So I think we talked a bit about the verification plan, at least in high level, and the expectations and how to do the strategy and how to really understand what's in there in order to
So regarding the
review
verification
that.
plan, so it's the what and the how, and another thing is how do you know that it is really done? It's
Oh,
the most
exactly.
important thing.
That's exactly what I wanted to ask you
How you
now.
know that you did whatever you thought you did in the how, right? You did, and you think that this how covers the what, but you need actually, like a
When
forensic.
do you tap out? When do you say I'm done?
Okay, so I will talk about that, but I would like to add a point. So each point that you have in the test plan, you need to write also what is the criteria that say this is done. Is it coverage? Is it direct test? And if it's direct test, how do you know that this direct test, once what's written, it can run and pass a regression, it's still doing the same thing that you thought it is doing. So you have a lot of things. You need to be sure that when you say something is done and covered, it's done and covered, and you can prove it if you will go to a trial, right? And this is it. And
Got it.
the other thing now, how do you go to a tapeout? So we have, first of all, we have
You touched a few
sign off.
checklists, right?
You have a long and exhaustive checklist, right? But if you ask me, I can go with you, whatever checklist you give me, and I will still pass, and everybody will be happy, and nothing will be good, right? This is just to remind you. This is just to remind you what are the points, that we learn for our lessons learned. Each project we do lesson learn, right? To understand what we need to learn for the next project. And a part of them go to the checklist, not all of them.
Do you have any objective measurement of when you're ready for tape out, like a
Of
certain
course.
score for coverage or
Yes.
like mutation analysis report or whatever?
So we have several, okay? We have, first of all, coverage. So we need to be at 98% coverage, but it's not only the percent. I always tell the people, you can...
How do you know that the 99% is really 98? Sorry.
Right. And also, a lot of people no one wants to get and disappoint, in a review. So you have to we ask questions all the time. In each sign-off, the sign-off is not just, like a ceremony that gathers all the people and everybody's happy at the end. Oh, we did it. No. It's a tough thing. It's a tough thing. It should be tough. And I will ask very annoying questions, And I remember when I used to do sign-offs, right? I was very angry that, why this guy is asking all these questions? Of course we did that. Or why is no thinking about that? But this is exactly how it should be. It should be annoying. It should be terrifying. And this is the only way it works. The other way that, we are coming together and go over the checklist. Oh, everybody, everything is covered. We are all 98% coverage, right, score. We have
Claudio, I'm a bit
100%.
confused. Are you saying that the checklists are not enough in order to make a decision?
Checklists are enough if they are reflecting the reality.
Okay.
But you have to make sure they are reflecting the reality. And
How
you
do
have
you
to
do
ask the
that?
tough. The only thing I challenge, I ask questions. It's not only me, by the way, it's the culture, right? People are not going to these reviews just to attend, right? They need to come and prepare. We have cross-check reviews before the sign-off. That someone that is not related to this but has some awareness and know how to ask questions regarding the specific unit, full chip or whatever. It's not one sign-off that you do for the entire chip. It's a lot of sign-offs, right? And this is not one thing that the same checklist, yes. It's the same checklist, it's the same cross-check reviews, but for different units that you have tens of them, tens of them.
I guess the checklist is very long, but can you point, a few key items, must-haves that you guys are following?
Yes, so first of all, one of the things that we are doing that I think it's very unique, I don't know if we do also software coverage as a part of our sign-off. So for example, if I will use a driver for the DRAM controller, okay, and let's say I used and I run it as a part of the verification environment, levels, but there is one function or one line that I didn't cover. It might be okay because this line is not used. By the way, we do it along with the software guys. We are working on that together, and it's safe for them a lot of code and do cleanups because we see things they have in their code that is not used anymore. And so through it, or we do find things that we didn't activate a mode, and you have it in the driver, and you say, okay, do we need this mode? Why didn't we have it in the coverage? And we ask
Interesting.
ourselves, we do cross-check.
Software and hardware together. Really
Yes,
interesting.
this is
What
one thing.
else? Yeah. What else is key?
The other thing
Do you guys,
that
for
we are
example, do gate level SDF?
okay. This is the other thing. Let's talk about. We have three approaches here, right? We have the design. Let's call it design or physical design aspects of verification, right? So we have also in RTL we have these SDC simulations. We run SDC in RTL simulations, but we don't trust it completely. So we run gate level
Just for
with
the sake
SDF.
of everyone to make sure that everyone understands, when you say SDC, you mean that you're taking the scripts for the backend and
Right.
the timing and taking them into the simulation
Exactly.
and making sure that signals are getting disrupted based on what the actual hardware should be, right?
Exactly. Yes. For example, if there is a false path, right, it means that, if it's a false path, so output from some flop should never be used in any place, anywhere, right? Because it can be sampled with incorrect value, or you never know. So this is something that is an easy example to explain to you, but it's
Did
also
you
check.
see any actual bugs that were
Yes.
captured with that?
Definitely.
Really?
We always see. Because, first of all, we start early. People are always asking me that are coming from outside the company and join us, and they ask, why do you need to run that? Because, you have statics tools that can check that, right? Check CDC and RDC and stuff like that. But we do it sometimes before the guys from the design are getting there. We already can find it in simulation.
Yeah.
That's what we
And
try to do, right?
And at the end of the day, some of them are actually RTL bugs. Like if you didn't
Right? It's
implement a
sometimes
protection
RTL
for
bugs.
a multi-cycle path, it's an RTL bug. It's not
It can be also an STC bug, by the way. If it's
Right.
a false path that it was defined on something that is not a false path, by mistake, because
okay.
someone put a
Right.
star in the wrong place.
I think we reached the end of our chapter today. So I wanted to thank you very much, Claudio, for being with us here. Let's continue that on a third chapter together, and we can follow up. Yaron, any last words for this chapter 2?
Yeah, it's been a pleasure having Claudio here. We know a long way back, and looking forward to the next chapter.
Thank you, guys. It was really a pleasure for me to talk to you today, and hope to see you next time.
Yep.
See you soon.